Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Now here's a problem for today. For July 7th, 2018, it's problem number 19 from multiple choice section of the last exam MLC from spring 2018. Mark is covered under a defined benefit pension plan. You are given that the annual benefit payable as a life annuity due is 2% of the 3-year final average salary per year of service. Mark retires at age 65 with 30 years of service. Mark's salary in his final year of employment was $100,000. At the start of each of the last 3 years of employment, Mark's salary increased by 3%. Mortality follows the illustrative life table. Interest rate is 6%, which is the rate used for calculation of actuarial present values in the illustrative life table, so we can use the values from the life table for actuarial present value of life insurance or life annuity. And then Mark chooses to take his benefit as a 10-year guaranteed whole life annuity due. Calculate the annual payment he will receive using the equivalence principle. So let's write P for that annual payment that we're seeking. And we use the equivalence principle to write on the left-hand side the total annual benefit times A.65 is the actuarial present value at at the time when he retires, discounted from the future because we multiply it by A.65. Well, it's 30 years of service times 2% per year of service times the 3-year final average salary, which was $100,000 in the last year, $100,000 divided by 1.03 in the year before, and $100,000 divided by 1.03 squared the year before, so 2 years before retirement. In the year of service, 2 years before retirement. And that's equal to P, the annual benefit, times A.10 for the certain part of a 10-year guaranteed whole life annuity due, plus deferred by 10 years, so 10E65 is the actuarial discount factor for those 10 years, times A.75, which is the life annuity starting 10 years from now, if given that he's alive, and that probability is included in 10E65 factor, present value of a unit annuity, life annuity due at age 75 is A.75. And the valuation rate is 6%, so we can use values from the illustrative life table. Well, 10E65 is 0.39994. A.65 is, and by the way, in the table it's already 1,000 times 10E65, so you need to divide that number that you get from the table by 1,000, and you get this. A.65 in the table is given as 9.8969, A.75 is given as 7.2170. And P from all this is then equal to the total annual benefit times A.65 divided by the present value of a unit 10-year guaranteed whole life annuity due. And just plug in what A.65 is. Well, of course, we can calculate A angle 10 at 6%. We plug in 10E65 and A.75 and then do the calculation. And the answer is approximately 53,965.82, which is answer E. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.